choose to just mark my 1/10. I'm going to give myself some space like I'm zoomed in or something. And then I'm going to mark down here negative 1/10. And it went up, down, up. There you go. Got it?
Yeah.
What happens if you get this wrong? Like if you miss this, if you get that one wrong, what's going to happen?
It's going to set everything off.
Everything's going to be off. Everything's going to be off. In fact, when you go to plug it in here, if it's wrong, you're not going to get one, or you're going to get something that's not going to be, you're not going to be able to, it's not going to be a nice angle on your unit circle. So once you, if you start seeing that, something's off. What if I asked you for another period of this? Okay, so yeah, let's do it. How hard would it be to get another period?
We could do what you just showed us.
I could do the little jumps, couldn't I? I could do the little jumps. Where was I? I was at 1 pi over 14, 2 pi over 14, 3, 4. I should have what? 5, 6, 7, 8, right? So let me see. I was at 4. This one was 8. Hold on. I'm going to write them down here. This one was 5 pi over what? 14. Next one is 6 pi over 14, 7 pi over 14, and 8 pi over 14, right? That's what they are? But we would want to reduce those fractions. So, yeah, some of them reduce, some of them don't. This doesn't, right? This reduces to be what?
3 pi over 7.
3 pi over 7. This one is just pi over 2, right? 7 and 14. And then this one, 4 and 7. Do y'all see how I got those? And then I could, again, say this is the end point, this is the middle, and then I've got my quarter marks there. So it goes up, comes down, comes up. That's your 2 periods. Good. Let's talk about cosine. You feel like you could do these? Like if you gave these different numbers here and different numbers there, you could handle them? Okay. All right, now the difference between sine and cosine. What's the difference on the unit circle? What's the difference between sine and cosine? It's whether or not you're looking at the x-coordinate or the y-coordinate, right? That's what it was all about? So let's see here. If I look at cosine, so this is that same picture I had earlier, but now with cosine, it's spitting out the x-coordinate. So when my angle is 0, right? When my angle is 0, that means my input is 0. What's my x-coordinate? The x-coordinate is 1, right? So look, at 0, my cosine graph's going to start up here. And what's going to happen is I start to open that angle up, which moves us across here. What happens is that angle starts opening up. What happens to my x-coordinate? So if I bring this angle up here, what happens to that x-coordinate? Does it go out? Does it come in? Does it stay the same? It should come in. It should get shorter, shouldn't it? Let me move it, and you'll see what I'm saying, hopefully. If I open that angle up, I've now moved down the x-axis here. But what happens to the distance from here to here? That's my x-coordinate. It's now smaller than 1, isn't it? And notice that the graph now came down. Why does that say pi? That should be not pi's there. Well, I'm not going to change it now. So do you see what's happening as my angle is opening up? My x-coordinate is starting to get smaller. And you can see the graph coming down. Yes?
Oh, okay. Instead of
Do you
starting at 0, it's going to start at the top.
It's starting at 1 because it's the x value as opposed to the y value. So my x value here is starting to get smaller. When I get 90 degrees, right, my x value is going to be 0. And that's why when I get right there, you can see on the graph, my value is 0. And as I go around, what's going to happen now as I continue moving around this? As I move this angle here, what's my x coordinate? It's growing and it's negative, isn't it? And what's the biggest negative value it's going to take on? -1. And then it's going to be negative, but it's going to start getting smaller. The x value here is going to eventually come back to 0. And now it's going to be small positive numbers until it gets back to its largest value of 1. And in that full revolution, we've completed one period of cosine, and that's what it looks like. So there's some differences between the sine and the cosine, obviously, right? Sine, the way we were graphing it is we said, okay, we had these two important endpoints, right? Those were x-intercepts, weren't they? And then we had a middle point, which was also an x-intercept. And then we did these little quarter marks, and we figured out if it was going up or down. That's the way we did sine, right? Cosine is going to be different, though. We still have something happening at 0 and 2 pi, don't we? We have the two high points. We only have 2 x-intercepts this time as opposed to 3. And don't the x-intercepts take place at the opposite of what sine was? Like sine, this is where our peaks and valleys were, right? But in cosine, that's where our x-intercepts are. So when we look at this for cosine, we can still break it into 4 equal pieces. We can still do the same method we did here. But this is an x-intercept, and this is an x-intercept automatically. Yes? And then it becomes the question of, do we have a high point here and here, and a low point here, like this picture? 2 high points and a low point? Or is it flipped over where we have two low points and a high point? So does it look like this? Or does it look like this? Do you see the two scenarios we have? So we're going to have to test a point just like we did, but it's going to be slightly different than sine. I think we should just do an example to see how it's going to work. Do you have a question?
I guess it's just like sine. We're just working with the middle, plugging the middle term in, or
yeah, we're going to plug in like the middle, or we could even plug in one of the edges. Because once I know that this one is up, the one across them, it has to be up, and that one has to be down. All right, let's do one. I so bad want to tell y'all this joke that my wife told me last night, but it's highly inappropriate, and I can't do it. Oh, I'm doing cosine. I think nowadays I can't do it, unfortunately. Maybe about 5 years ago I could have. Let's go cosine 4x. The first example we did with sine was sine 4x, right? So let's do cosine 4x. So I start this whole thing off by doing this. I know that the basic cosine function looks like this. It has four important points. That's not supposed to be there. Right? It has 2 x-intercepts here, like that. So now I'm going to do the exact same thing. I'm going to set the argument equal to 0 and 2 pi. 4x equal to 0, 4x equal to 2 pi. Now just follow me through this for the first one. That work is exactly the same as it was for sine, right? The difference is going to be in the graph and what you do at this point. So I'm going to come to my graph, and I'm going to mark off 0 and 2 pi. And notice I did not put dots there. Because this is cosine, not sine. Sine has x-intercepts at the end, right? And then one in the middle. This is a cosine function. It doesn't do that. So I've got these two just marked out. Then I'm going to mark halfway. What's halfway? Why did I put 2 pi? I have no idea why I put 2 pi. Sorry. This should be what? Pi over 2. That's what I got here. Okay, so now I need to mark halfway. What's halfway? Pi over 4. And then I need to mark halfway between these two. And so I have to compute those, don't I? This one will be pi over 8. And since we did that earlier, this is 3 pi over 8, right? We got those? What do you think I should do now? Plug in a test?
Yeah.
Before that, I know my x-intercepts. Where are my x-intercepts at? Pi over 8 and 3 pi over 8. See the difference in this between this and sine? With sine, you go 2 outside and in the middle. With cosine, you have to find all of them first and then mark your first quarter one and your third quarter one. Does that make sense? So now I need to figure out if this piece right here, when I plug in 0, if I'm going to be up here or down here. So why don't I test 0 out? And I just plug it in there. So what would I get if I plug in 0? Cosine, well, 4 times 0 is 0. Cosine of 0. So on your unit circle, your angle is 0, and cosine is the x-coordinate. The x-coordinate, what's the x-coordinate here? 1. So this is 1. And so you are right here at 1. That good? Now look at the way cosine functions look like. I mean, look at this. If I'm up here, then all the way across at the end of the period, right? Here is where I have the other one. So I'm going to go to pi over 2 and go up 1. I know that's marked, right? And then right in the middle, I should be at the bottom. So that's going to go down 1 like this. And I'll mark that over here as negative 1. Mm-hmm. What, this point right here? Yeah. That's the end of the curve. Okay. That's all it is, just the end. So now I can draw, right? And I'm doing smiles and frowns. I'm not doing anything other than smiles and frowns. So got the right side of a frown, left side of a smile, right side of a smile, and left side of a frown. And that's one period. So when it comes to graphing sine and cosine, the fundamental difference is where the x-intercepts are, right? That's the main thing. And then it's what you plug in, what you tested. I tested 0 here. When we were doing sines, we had to test one of these guys.
You can always test 0 for cosine.
For cosine, you can always test 0 as long as we haven't phase shifted it. Later on, we might phase shift it. And again, this point won't land there. So how do y'all feel? Okay, why don't I give you one to work on? I've only shown you one cosine. I'm going to give you a cosine to work on. Why don't you work on it in groups? You don't have to turn this in. I'm behind on grading right now, so I don't need something else to grade. Let's see how you do with this. There you go. I would like for you to graph that cosine function. Help each other out. And we'll take some time on this, okay? At least a good 10 minutes.